So you found out that an Oreo cookie contains 71% of the cookie wafer and 29% of cream. What can you do with this information, and what does it have to do with chemistry? So what does the percentage represent? For example, on a 100-question test, you received a 91%. Woo-woo! What does that mean? It means that you answered 91 questions correctly out of the 100 questions. You can write a conversion that you have 91 questions correct over 100 questions total. Please note that you just don't write numbers, but we label what each number represents. So what does that mean? In an Oreo cookie, there's a 71% cookie wafer and 29% of it is cream. You can write two conversions with units and words describing the measurements you made. And then we can calculate the mass of cream in an Oreo cookie that has a mass of 65 grams. We see that there is 71 grams of cookie wafer and 100 grams of cookie. There's also 29 grams of cream and 100 grams of cookie. We get that from the percentages. So we can use one of the conversions above when we calculate the mass of cream in an Oreo cookie. It's important not to be tempted to multiply by 65 grams by 0.29 as units are missing, and when we apply this to chemical compounds, you'll just get confused. So if we want to start with 65 grams of a cookie, we want to calculate the mass of cream. That means we use this conversion. Here we see that 65 grams of cookie converts to grams of cream by using the conversion 29 grams of cream over 100 grams of cookie. Therefore, cookies cancel, and you're left with grams of cream. So what does this have to do with chemistry anyway? For example, consider the problem. The FDA recommends that adults consume less than 2.4 grams of sodium a day. How many grams of sodium chloride can you consume and still be within the FDA guidelines? Well, we have to go back to our previous homework where we use percent by mass of sodium and sodium chloride, and we will need to review how to calculate the percent of sodium and sodium chloride. To calculate the percent of any element in a compound, you take the total mass of the element divided by the total mass of the compound times 100%. Please don't forget to include units and the chemical formulas. So for example, 23 grams of sodium is in 58.44 grams of sodium chloride. The 58.44 grams of sodium chloride is the molar mass of sodium chloride. When we divide that and multiply by 100%, which I forgot to show here, you get 39%. Well, this is the same relationship as 39 grams of sodium and 100 grams of sodium chloride. So let's identify the givens and find our problem. You have 2.4 grams of sodium, and you want to know how many grams of sodium chloride a person can consume in order to remain within the recommended FDA guidelines. We'll perform the conversion and check to see that our answer makes sense and to see what it means. So if we start with 2.4 grams of sodium, and that's the recommended FDA guidelines, and we know there's 39 grams of sodium and 100 grams of sodium chloride. So a person can consume 6.2 grams of sodium chloride and remain within the FDA guidelines. Please note that the units and chemical formulas cancel, and notice what the answer means. So here's a problem for you to try. A woman consumes 22 grams of sodium chloride. How many grams of sodium chloride does she consume? And is she over the FDA guidelines? Please pause the video and set up the problem before you check your answer. So, we know the given is 22 grams of sodium chloride. Previously, we determined that there's 39 grams of sodium in every 100 grams of sodium chloride. So we calculate, oops, I forgot to label it. She can consume 8.5 grams of sodium. I forgot to label it sodium. Please do so on your paper. For your homework tonight, you have notes from your e-text, and be sure to refer back to the example where they calculate the percent composition, and you just have 2 problems to do in your textbook. Thank you for watching. Have a great night.